In this video, we're going to do a deeper dive into prompt caching. I came across this recent post by Tariq, who's an engineer on the Claude Code team, talking about how prompt caching is one of the most important things when building products like Claude Code. It allows you to reuse computations from previous round trips and significantly decrease latency and cost. Prompt caching is the technique that makes the economics of a product like Claude Code work. Every time you send a message in Cloud Code, the entire conversation, your system prompt, your tool definitions, your cloud.md, all your previous messages, they get sent back to the API. The prompt caching, what it does, it stores the computation from processing these tokens before so that the model doesn't redo the work it's already done. Cached reads, it costs 90% less than normal input. So if you go look at the pricing on the page here, like if you see, reads are 50 cents per million tokens, whereas it's 5 per million tokens if it's not a cached read. So they're significantly cheaper. And in this video, we'll see how prompt caching works under the hood and what you should be aware of when you're using Claude Code so that you don't accidentally break prompt caching. So let's take an example of what exactly happens when you send a message. When you type a message and send it to Claude Code, your actual message is a small part of what actually gets sent in the API request. This full package is called like the context window. So let's take a look. So when you send a message, let's say I want to fix my login bug. The system prompt gets sent, the tool definitions, your cloud.markmd file, and then your actual message. So the full context window is significantly larger than your message. So now let's say you send a message, you got something back from Claude. Now you want to respond back to that message. So every single turn or conversation is called like the turn. So the whole history is resent and reprocessed because the model does not have any memory between the requests. So let's watch what happens in a regular coding session. So in the turn one, you maybe sent 18K tokens, came back, you sent another message, and you kept going back and forth with Claude. So let's say you hit the 200K token limit on turn 50. If the pricing was like $5 per million tokens and there was no caching, a 50 turn session, for example, with 5 million input tokens would have cost you like $25. So imagine having each coding session cost you $25. That would be too expensive, and there's no way you would use Cloud Code, and the economics would not work out. So this is the problem that prompt caching is solving. So another way to think about this is you can think of how you would grade an essay. So let's say a student hands you a 10-page paper. So you read it and you make notes along the way, circling key points, drawing connections between the different paragraphs. So like you would read all of these notes, you would make some notes. These notes are basically saved. You can think of this as the cache. So as you're reading it, you're saving the notes. That's the internal computation for each token. The one key thing to remember is that the model's response is generated fresh every time. Caching is only saving what it's reading or what is already read. So now let's see an example. Maybe the student forgot to send one page to you, so he sends you page 11. So you wouldn't read all the 10 pages again. You already read the 10 pages. You already have the work saved. So you just have to process page 11. If you didn't have caching, you would have to read all of the 11 pages. But now you already have the notes that you wrote down somewhere. But what happens if page 3 changed? If that's the case, like your page 1 and 2, you can still need the notes from that. But everything on page 3 potentially impacts everything that comes after that. So any change on page 3 means that the cache is void and you have to read through all of the work that you've already done. So that is why this is how the caching works. Each page's notes depends on everything before it, never on what comes after. So changing anything early makes all of the notes after it invalid. So this is one of the key factors you need to remember when we talk about how to make sure that you're leveraging prompt caching. So this is how prompt caching works. So you send a request, Claude Code has the full context window. It checks the server to see if the prefix of this message is the same. Do I have it in the cache? If it has it in the cache, it'll load it from the GPU memory, and then it only processes the message that needs fresh computation. So like I said before, an old message of the regular input would have $5 per million tokens, whereas a cache read is like 10 times cheaper. So it's like only 50 cents per million tokens. So a session with a 90% cache hit rate costs significantly less than what would have cost if you were processing all of the input tokens all the time. One thing to remember is the cache is only valid for 5 minutes. So if your sessions are very long and if they're lasting way longer than 5 minutes, the cache will get reset and it will have to do the cache computations again. So that's another thing to keep in mind. One key thing to remember is that the 5 minute timer is for idle time. So as long as you're actively conversing, that 5 minute TTL keeps renewing. It's 5 minutes of idle time. So if your session is going on and you're sitting in the background and you haven't it's been idle for more than 5 minutes, then your cache expires. So that's something to remember is it's 5 minutes of idle time. So like we said before, how do you make sure that you're leveraging prompt caching? You have to make sure that you do not change anything earlier in the session in the context window because that will void your cache. So what does that mean? If you add a new message, that's fine. Like that's the regular scenario. You would get a cache hit because the prefix is the same. Only write a test message in this case will get processed. But for example, you were to go and change the system prompt or change your tools, that would be a cache miss because system prompt is literally the first thing in your message. So all of this would lead to a cache miss. So I tested this by against using the Claude API, and if you change the system prompt, you would have like my prefix cache read 0 tokens. So it broke everything. So do not change your. So make sure that any dynamic things in your messages are always towards the end. Do not change anything static in your messages. So static content, like I said before, static content first, dynamic content last. The prefix never changes. This is from the advice from Tariq, who talks about make sure that best way to do this is that the static content is first. So for Claude Code, system prompt and the tools are always in the beginning. Then the Claude.md file, the session context, which is cached within a session, and then the conversation message is always at the end. So an example where you can accidentally break this is by putting in a timestamp in the static system prompt. So they talk about how they broke this caching by accidentally putting a timestamp. Timestamps are non-deterministic, so you never want to put a timestamp in your system prompt or anything like that. So if you accidentally add an MCP tool during a session, that actually breaks prompt caching. Adding a tool, so all of the 18K plus tokens after that have to be reprocessed. So this is why Claude Code uses deferred tool loading. If you have a lot of MCP tools, do not put a timestamp in your system prompt like we just saw. Do not switch your model halfway through the session. The caches are per model, so this will lead to Haiku having to build its own cache. So sending a new message is fine because that always happens at the end. So lastly, I think we'll talk about like what is compaction and how does that impact prompt caching. So a session grows till the context window is full. So in this case, messages will keep growing as you have more turns. And then the context window is almost full. It triggers auto-compaction. It tries to keep the prefix the same. So compaction, like Tariq mentioned this, compaction is basically a fork. It keeps the same system prompt, keeps the same tools, and keeps the same Claude.md. And then it adds a summary message here. So only the compaction message is appended as a new message. So the cache prefix is reused. So they want to make sure that they're leveraging like the benefits of prompt caching wherever possible. So yeah, lastly, cache tokens cost 90% less than normal input tokens, so it's saves you a lot of money, like we just saw. If you have a cache rate of 90% and you're using Opus and your conversation like has 100 turns, like it's a significant difference in how much money you would save. So I think Tariq also mentioned like basically the Claude Code teams treat their cache hit rate like uptime. They declare savs when it drops. So yeah, um, they have anecdotal data that real Cloud Code sessions generally are 96, 97% cache hit rate. So yeah, this is from my data. Feel free to check yours. But yeah, that's a deep dive into from caching. There are some good resources here from Tariq. There's this. I also wrote a blog post in detail about this. I'll link all of this to the video. Feel free to take a look. I also have a newsletter that I write about tips that I'm learning from Cloud Code. Feel free to take a look. And thanks for watching.